Hi everyone, Tim here. Today we're going to be talking about the part 2 of the laws of exponents. For today we'll be discussing the negative exponent law, the power of a power, the product of a product, the power of a product, and the power of a quotient. Let's dive straight into it. The negative exponent law. The best way to think about this is if we understand that addition is the inverse operation of subtraction. So this is what I mean by that. Let's assume I start with the number 2 and I add 5 to it. The answer is 7. And then I decide to reverse the operation, right? 7 minus same number 5, I'll be back at 2. So that's why we say addition is the inverse operation of subtraction. The same thing with multiplication. It is the inverse operation of division. So let's say we say 2 and we divide it by 10, which can be written as 2 over 10. That becomes 1 over 5. We write it in its simplest term. Same way, we reverse the operation and say 1 over 5 multiplied by that same number 10, that is equal to 2. Now we are back at the original number 2 that we started with. And so we say division is the inverse operation of multiplication or vice versa. So let's look at it from the point of view of this law that we're talking about. A raised to the power minus m is equal to 1 over a raised to the power m. If you look at this very carefully, it looks like we're saying that negative exponent, which is this, is the same as the inverse of the positive exponent, which is kind of easy to understand if you understand that positive is the inverse of negative and multiplication is the inverse of division, right? So let's take an example. 2 raised to the power minus 3. If we are to evaluate this and follow this law, that means we would be saying it is the same as 1 divided by 2 raised to the power 3. Right? So 1 divided by 2 raised to the power 3. Let's think about this for a second. So we're saying 2 raised to the power minus 3 is kind of like repeated division. 1 divided by 2 raised to the power 3, and that will be equal to 1 divided by 2 times 2 times 2. And we can rewrite this as 1 divided by 2 times 1 divided by 2 times 1 divided by 2. And that will be equal to 0.5 times 0.5 times 0.5. If we punch all this into a calculator, we get 0.125. So if we look at it from this formula perspective as well, right? Or the law, from the perspective of the law, what the law says we should do, right? 1 divided by 2 times 2 times 2, that's equal to 1 divided by 8, right? And if you punch 1 over 8 in the calculator, what you should be getting is 0.125, which kind of proves the law, right? Here it is 0.125, and here as well it is 0.125. So we can think about this as some kind of repeated division, right? If we have a negative exponent, then we know we are talking about a repeated division. So this simply means we're repeating the division 3 times since it is negative exponent. Let's go to the second law. The second law is power of a power. So what this is saying is that if you have a quantity that has a power already, right, the base of that quantity is a, and the exponent of that quantity is m, and this entire quantity, right, is grouped together in a bracket or in a parenthesis, and that quantity, we're raising it to another power. The law is simply telling us that what we need to do to evaluate that is to multiply the two exponents together, right? and we can rewrite this simply as a raised to the power mn. So let's take a quick example. This is saying 2 raised to the power 3 all raised to the power 2, right? Where our m is 3 and our n is 2. Our base a is 2, right? So this can be rewritten as 2 raised to the power 3. That is 2 times 2 times 2 all raised to the power 2. So that's 8 raised to the power 2, which is the same as 8 times 8, multiplying 8 by itself, and that is 64. So let's see what the law is telling us, right? By using the exact same example. The law is saying that a raised to the power m grouped together raised to another number raised to the power another exponent n will be equal to a raised to the power mn, right? So that would be 2 raised to the power 3 raised to the power 2. And we can rewrite that as 2 raised to the power 3 times 2. 3 times 2 is 6. And that will be equal to 2 raised to the power 6. If you punch 2 raised to the power 6 into a calculator, what you will be getting is 64. So the law has actually been proven here, right? It means the law holds true. 64 on the left-hand side based on doing it this way, and based on doing it the other way, we also got 64, which also proves this law of power of a power. Let's look at power of a product. This one is a little bit different than the ones we did before. This one has two different bases, right? So pretty much this one is telling us that if we have two different numbers which are bases, right, and they are multiplied together, everything raised to power m, the law is telling us that we can distribute the exponent across both of them, right? So that would be a raised to power m. M is distributed on a, and then it's multiplied by b distributed on m. So to understand this better, let us just take a quick example. 2.3 all raised to power 2, right? So if we want to evaluate this without having a prior knowledge of this law, it means that we'll be saying 2 times 3 all raised to power 2. 2 times 3 is 6. 6 raised to power 2. That will be equal to 36. Now let's use the law. The law says that we can distribute the exponent across the two different bases. So this will become 2 raised to power 2 times 3 raised to power 2, right? This becomes 4 times 9, and that's also equal to 36. So as we can see on the left-hand side, the final answer is 36, and also on the right hand side the result is 36. So that tells us that the law holds true. So again, do not forget that you do not need to memorize all of this. With practice, it will subconsciously become part of you. That's why it is so important to practice. Let's go quickly to the final law for today. That one is talking about the division of two different numbers, right? So just like we have two different bases that were multiplied together in the last law that we discussed, here we have two different bases that are divided by one another. So it's saying that a divided by b all raised to power m is equal to a raised to power m, that is distributing the m by the top and the bottom, and b raised to power m. If you want, you can also reverse the process, right? You could say a raised to power m divided by b raised to power m is equal to a over b all raised to power m. We are saying the same thing. They can be used interchangeably. So let's take an example. Say 4 divided by 2 all raised to power m, right? So we're saying 4 divided by 2 all raised to power m. Let's assume our m in this case is 2. And so I'm going to clean off this m, and I'm going to set m to be equal to 2, right? So to simplify this, we would say 4 divided by 2 for sure is 2, right? So that would be 2 raised to power 2, and that is equal to 2 times 2, and that's equal to 4. Now, let's look at what the law says. The law says that we can distribute the exponent m over the two different quantities that represents the basis in this expression. So that will be 4 raised to power 2 all divided by 2 raised to power 2, right? And that becomes 4 raised to power 2 is 4 times 4 divided by 2 times 2, right? And that becomes 4 times 4, 2 times 2. So 2 can go into this, remaining 2, and that 2 can also cancel this as well. So the final answer for that is 4. Again, we've been able to prove the power of a quotient law of exponents, right? Because on the left-hand side, the final answer is 4. On the right-hand side, the exact same number resulted. So that's all I have for you for today. Again, if you do not understand any part of this tutorial, please be sure to leave in the comment and we will provide a more comprehensive explanation. Please subscribe to our channel if you have found some value in this video. Share with your friends, they will also get some value from it. And do not forget to click on the bell icon so you will be the first to know when we upload a new video. Bye bye. See you next time.